Here in this part. So here we have the settings of the network. So, but here not all the settings that we can do. We can find it, the settings, because it's quick start configuration maybe. Yeah, configuration. Yes, here are all the settings. Okay, so let's try to find the one which is the confidence. This is a way to make your model better. Okay, train guide. Okay, here, conf. This is the confidence. So sets the minimum confidence threshold for detections. So then you add this argument in the training and you put the value that you see in that F1 curve. Okay. All right. YOLO is also very good in other things like uh, augmentation, data augmentation. So you have a short data set and you can use also, including the arguments, um, some variables to augment the data. For example, degrees, it will rotate the image. So you have a pore rotated in different angles. And also translations, scale change. So you can add all this information in the code. Yeah. And you will have here more freedom to work with the parameters, and also you will have a better model at the end. Okay. Then let's have a look in other things of these results that were produced. Here it generates also some examples of the train batch. So you can see that in the train batch, it has done some detections of the pores. But let's see the validation. Okay, this is the validation of the model. Okay, now we can see what the model would really detect. For example, you see here, it has detected pore. This is the probability of be a pore is 0.5%. Also here with these other images, you have the detections that the model did in the validation images, okay? And if you see here, all the pictures we have, even a pore with some dirt here inside, it was detected. A small pore was detected. Here is a drop of, well, it didn't detect a spore, it's right. So it is quite accurate, this model in detecting the defects here for this case. Also here, the small pores. Here you can see that we have oxidation points, and this is not detected. Only the pores are really detected. And this is due to the distribution of pixels that the pores have. So it learns the pattern, and then it will try to find in the image this pattern. Okay. Then this here we can see that the model is performing well. And I would like to share with you that the amount of data was not that big to have such nice results. If you go to the images and the train data, we had only 86 items, like 86 images. And only with these images, but also, don't forget, I have used to train this model here, the data augmentation techniques like rotation, translation, and also scaling these things. Yeah. And then I could get a more robust model. But for you to have an idea, with 86 images, I was able to train a model that can correctly predict and identify pores. Okay. So, are there any questions or comments so far? If not, I think I would share with you, we still have time, another way to do that. Okay, and maybe you don't have Anaconda installed at your computer, okay, and you would like to do a quick test, and for that we can um, try using the Google Colab. Okay, I will share with you how to do it. This is very quick. So all what you need is a Google account, nothing more for that. And then you have to upload the data to your drive. And okay, then let's do it using Google Colab. So to create a new script, you should go here, new, more, and Google Collaboratory, and then you'll be directed to the Google Colab. Okay, and there are few things that we should do before is to mount the drive, the Google Drive, to be accessible by this notebook. And to do that, let's put mount Google Drive. Okay, then from Google.colab import a drive. Then drive mount, and then we should specify the path, and it is content and Google Drive. This I know already because I have used for many times. This is just to have the data accessible. Okay. Then we press Shift Enter. This is a standard code to have access to the data. It takes. I probably wrote something wrong. Content, drive, mount. Google, I wrote wrong. So typos happen. And these are the most horrible type of errors. A typo, like you, sometimes it takes time to find. I would just have to permit the access to okay. So here's not. This is odd. Okay. Maybe I did something that didn't work. Okay, let me check quickly here. It's important to have access to the data. If not, cannot do anything here. Okay, I don't know what happened. Now it's working. And then we have to define the root directory. Okay, and then do that. And then it will be root. This is the variable that I am creating, directory. It's equal to content drive and my drive and training. Okay, this here. My drive training. The T is capital. Okay. This was just to have the data accessible. Okay. And now we will start the library of Python of YOLO. And this is, let me install the Ultralytics library. For that we have the information in the website of the documentation of the Ultralytics, which is this one here, pip install Ultralytics. Mm-hmm. Here. Now we are installing the library. This generally take less than 1 minute to have it done. Okay, it's installing. You can see here. Let's wait until it's finished. We are almost there. And this makes really simple because you don't have to install anything on your machine. You can just run it online and you have the same results. So yeah, 1 minute here says took. It's finished. Now we have the library installed. Then for path issues, we have to import one library called OS. And we will import from Ultralytics the YOLO. Okay. Everything was imported correctly. Then if you remember in the documentation, here we will load a model. I will use this. Load the model. Okay. Model was loaded. And then we can train the model also using the command that we find here, like in the documentation. There is something we have to do is runtime. If we can change the runtime to use free GPU that we can use to train the model, so it will be much faster. And I will activate it. Okay, I will have to re-import the things, but I don't have to install the library anymore. Okay, what we are going to need as well is this YAM file. That is this default. We have to add here one configuration file. I think I have it here done. Let me check. Yeah. Let me just check here. Yeah, we have to add it there. Mm-hmm. This can remove. Mm-hmm. Okay. Yeah. I'm just here generating this file to add here. Yeah. Meanwhile, the situation is the same as in the local host with the computer. The difference is just that you can do it online. And if you don't have your host computer with a nice GPU card, and you can borrow it from the Google Colab, and you can do the training much faster. Yeah, and this is a solution in the case it's needed. Yeah, and this is an alternative for doing that. And after that, I will do one last thing. Okay, let me check that I will show you in real-time detections, but let me finish this here first. And then you can really see how powerful this machine, this algorithm is, the YOLO algorithm, for real-time detections. Because until now we have worked with images, but we could have used also videos, and we could also do using real-time videos using this tool. Yeah. Okay. Okay. This. Yeah. Okay, then let's train the model and let's see what happens. I will put here like one epoch just to show you. And patience, this we don't have to care. It's like if you have 30 epochs, after 5 epochs, if the result doesn't change, it stops before finishing the cycle. You just say, okay, it's enough. We don't need to continue. Okay, there is a path error. The path error here with this file, yum file. How it's it here? Maybe it was some typo. Let me check. Okay, the name was wrong. Okay, now should work. I was using the wrong file. So now we are training the model with the Google Colab in the same way. Okay. So we are almost done. Okay, it's training. Okay, trained. You see how it was faster compared to the local host. Okay, then that's it. We can have also your model trained here. And just to finalize, I would like to do one short demonstration. Uh-huh. Let me just check. Okay, I will do one test. Uh-huh. Give me a moment, I'm loading here things. I will run here trained YOLO. Okay. Uh-huh. Okay, this should work. What I have. Okay. Okay, I cannot access the camera with while I'm using it. I was going to use my webcam to show you real life detections. Let me turn off my camera. Then we can probably try again. Okay. Then let me try again. Okay. I will put here. I think you can see my screen. You see that the YOLO is detecting me as person. It's detecting behind me a chair. This is in real life. And it's also detecting this as a book, now as a cell phone, but it's a book. Yeah. And let's see. This is a cell phone. Okay, it's detecting a cell phone. So we can, with a trained YOLO, detect in real life many things. I don't have here a piece, a coupon of weld, but I could also stand here in front of you, one piece of weld, and with a training YOLO, it would detect in real time the pores, the defects. Okay. So then from my side, that's all I had to show and to demonstrate for you. I hope you have enjoyed and learned something. And please, if you have some question or comment, let me know, and I will be glad to help you. Yeah, thanks to you. Okay, so then I think we are done here with this training. And yeah, please contact me if you have some doubt and want to do something to investigate defects with YOLO. We can collaborate. Okay, so I wish you all a nice continuation. Yeah, and yeah, that's all from my side. Don't know is there's some consideration from someone from some side. No. Then I think we can close this training session of the PeneloPe project. And thank you all for attending. And yeah, see you next time. Bye bye.